Our world is being reshaped by human ambition on a scale that would seem like pure fantasy just decades ago. Today, we're diving into the most audacious megaprojects ever conceived, engineering marvels so massive they're redefining what's possible when billions of dollars meet human determination. If you're ready to witness the impossible made real, hit that subscribe button right now, because what you're about to see proves that when humanity decides to dream big, there are no limits.
So if you want more journeys into the unforgiving, the beautiful, and the unknown, subscribe. Hit that button and join us as we explore the places that don't fit on postcards.
Let's explore these monuments to human ambition. The Palm Jumeirah rises from the Persian Gulf as an artificial archipelago shaped like a palm tree visible from space, created by dredging 94 million cubic meters of sand from the ocean floor. Construction began in 2001 when engineers decided to extend Dubai's coastline by creating entirely new land in the middle of the sea. The project required 7 years of continuous work, moving enough sand to fill 2.5 Empire State Buildings every single day. The palm trunk extends 5 kilometers into the Gulf, while 17 fronds branch outward, each lined with luxury villas that have direct beach access on both sides. A crescent-shaped breakwater 11 kilometers long surrounds the entire formation, protecting it from waves and currents that would otherwise wash the sand away. This barrier required 94 million tons of rock quarried from the mountains and transported to sea, then carefully placed by divers working in shifts around the clock. The engineering challenge was immense. Sand doesn't naturally stay in palm tree shapes underwater, so the entire structure needed GPS-guided placement with accuracy measured in centimeters. 7,000 tons of rock formed the foundation, while vibrocompaction technology pressed the sand into stability that could support high-rise buildings. The island added 78 kilometers of new coastline to Dubai, space for homes, hotels, restaurants, and entertainment complexes that attract millions of visitors annually. From ground level, you barely grasp the scale, but from above, the perfect palm shape emerges from the blue water like a logo stamped onto the ocean itself. The project cost $12 billion and employed 40,000 workers simultaneously at peak construction, making it one of the largest land reclamation efforts in human history. Standing on the palm's outer crescent, you can watch waves that travel across the entire Gulf break harmlessly against the barrier, while the water inside remains calm as a swimming pool. This is humanity announcing its presence to the cosmos, building landmarks visible from orbit, proving that even the ocean can be reshaped according to our designs. The Three Gorges Dam spans the Yangtze River in China as the world's largest hydroelectric power station, 2,309 meters of concrete, holding back 663 kilometers of reservoir. Construction required relocating 1.3 million people from 13 cities, 140 towns, and over 1,300 villages that now lie beneath the water. The dam stands 181 meters tall, a wall of concrete that transforms one of Earth's greatest rivers into a controlled flow of electricity-generating potential. Its 34 generators produce 22,500 megawatts of power, enough electricity to supply roughly 70 million people with everything modern life demands. The reservoir behind the dam is so massive it holds 39.3 billion cubic meters of water, weight sufficient to measurably affect Earth's rotation by shifting mass toward the equator. Scientists calculated that the dam increased the length of each day by 0.06 microseconds, a tiny change proving humans now engineer on a planetary scale. The project cost over $30 billion and took 17 years to complete, requiring pouring of concrete continuously while the Yangtze flowed around temporary channels. Engineers face the challenge of controlling a river that drains an area home to 400 million people while maintaining shipping routes that move millions of tons of cargo yearly. The dam includes a 5-stage ship lift that carries vessels up and down the 113-meter height difference, replacing the treacherous rapids that once made this section of river deadly to navigate. The Three Gorges region was famous for its natural beauty, limestone cliffs rising dramatically from the water, much of which now sits beneath the reservoir created by the dam. Critics argue the environmental cost was too high. Fish species went extinct, archaeological sites vanished underwater, and the change flow altered ecosystems downstream for hundreds of kilometers. Supporters counter that the dam prevents devastating floods that historically killed thousands and provides clean energy equivalent to burning 50 million tons of coal annually. Standing atop the dam, you watch the Yangtze reduced to a trickle flowing through spillways, while behind you an artificial lake stretches the horizon, holding back pressure that could destroy the dam and everything downstream in one catastrophic failure. This is power and vulnerability combined, the largest thing humans ever built to control water, a structure that changed Earth's rotation and the lives of millions. Neom sprawls across 26,000 square kilometers of Saudi Arabian desert as a $500 billion vision of a city built entirely from scratch around future technology. The project includes a line, a linear city 170 kilometers long, but only 200 meters wide, designed so no resident is ever more than a 5-minute walk from nature and all services. The line will house 9 million people in a structure that stretches across desert and mountains, a mirror facade reflecting the surrounding landscape, while hiding the densest urban environment ever conceived. The city will have no cars, no streets, no carbon emissions, only high-speed rail running beneath the structure and connecting the entire length in 20 minutes. Engineers plan to build the city vertically, rising 500 meters above the desert with every level containing residential spaces, parks, schools, and businesses stacked in three-dimensional neighborhoods. The mirror exterior will minimize heat gain in a region where summer temperatures exceed 50 degrees Celsius, while narrow width ensures natural light reaches every interior space. The project requires excavating enough rock and sand to fill the Grand Canyon, moving it with autonomous vehicles and construction drones operating 24 hours daily. Neom will run entirely on renewable energy, with massive solar farms and wind installations generating power for air conditioning, desalination, and the infrastructure needed to sustain millions in one of Earth's harshest climates. The city will include an 8-sided floating port, underwater hotels, an artificial moon, cloud seeding technology to create rain, and glow-in-the-dark sand created by bioluminescent organisms. Critics call it an impossible fantasy, questioning whether anyone will actually want to live in a 200-meter-wide city that stretches beyond the horizon. Supporters see it as a necessary reimagining of urban living, a response to climate change that separates humans from the cars, sprawl, and emissions that make current cities unsustainable. Construction began in 2021 with a target completion date of 2030. Though experts doubt any megaproject this ambitious will finish on schedule. The first residents are expected by 2024, test populations who will experience life in the world's first post-carbon urban environment. Standing in the desert where the line will rise, you see only sand and rock, but the vision is a mirror stretching across mountains, catching sunset and sunrise simultaneously, reflecting a landscape humans decided to improve by building the longest structure in history. The Channel Tunnel connects England and France through 50 kilometers of underwater railway tunnels bored through chalk beneath the English Channel. The project required 11 tunnel boring machines working from both sides simultaneously. Meeting in the middle with such precision, the error was less than 2 centimeters. Construction began in 1988 after decades of political debate and false starts dating back to Napoleon's era, when the idea was first seriously considered. Engineers drilled 3 parallel tunnels, 2 for rail traffic and 1 service tunnel between them for maintenance and emergency access. The tunnels run an average of 45 meters below the seabed, deep enough to avoid ship anchors, but shallow enough to minimize the distance machines needed to bore through solid rock. Workers excavated 11 million cubic meters of chalk, enough to fill Wembley Stadium 3 times, removing it through shafts and depositing along the coast where it extended the shoreline. The French and British teams met beneath the channel in 1990, a moment celebrated worldwide as workers from both sides shook hands underground for the first time in history. The tunnel opened in 1994 after 6 years of continuous work that cost $15 billion. and employed 13,000 people at peak construction. 13 workers died during construction, deaths from accidents that highlighted the dangers of boring through rock beneath millions of tons of seawater. High-speed trains now cross the channel in 22 minutes, reaching speeds of 160 kilometers per hour, while passengers barely notice they're traveling beneath one of the world's busiest shipping lanes. The tunnel transformed European travel, making London and Paris closer by rail than many cities within the same country. Standing inside the service tunnel between the two main bores, you hear trains rushing past in both directions, while knowing that 40 meters of chalk and 45 meters of ocean separate you from the surface. The tunnel represents the final connection between Britain and continental Europe, a physical link that ended the island's geographic isolation and created economic ties that reshape European commerce. This is engineering defeating geography, proving that when two nations commit to connection, even the ocean becomes irrelevant. Burj Khalifa pierces the Dubai skyline at 828 meters, the tallest structure humans have ever built, so high that temperatures at the top can be 15 degrees cooler than at ground level. The building contains 163 floors above ground and requires its own microclimate engineering to deal with wind, temperature variation, and the physics of pumping water nearly a kilometer into the sky. Construction took 6 years and required pouring concrete continuously for the central core, raising it higher before the steel and glass exterior could be attached. The foundation alone goes 50 meters underground and required 12,000 cubic meters of concrete reinforced with steel to support weight that would crush anything less substantial. At peak construction, 12,000 workers from over 100 countries labored simultaneously, working in shifts that continued 24 hours daily without pause. The building's Y-shaped floor plan reduces wind stress while maximizing views, each arm of the Y containing residential, hotel, or office space with floor-to-ceiling windows. Engineers designed a tuned mass damper near the top, a weighted system that counteracts building sway during high winds that can push the structure several meters off-center. The elevators travel at 10 meters per second, making them among the fastest in the world, necessary because walking down from the top floor would take hours. The spire alone extends over 200 meters above the highest occupied floor, a steel needle that pushes the total height to a number chosen specifically to break records. On the observation deck at level 124, you can see the curvature of the Earth on clear days, watching the Persian Gulf extend to one horizon while desert stretches to the other. The building uses enough electricity daily to power a small city, most of it for air conditioning in a climate where outdoor temperatures make steel too hot to touch. Water must be pumped from ground level using pressure systems that overcome gravity trying to pull it back down, requiring engineering solutions that didn't exist before this building made them necessary. The Burj Khalifa consumed $1.5 billion and represents Dubai's ambition made vertical, a statement that money and determination can build higher than anyone thought possible. Standing at its base, you cannot see the top without leaning back. So far you risk falling over, the building disappearing into the sky like a ladder to space. This is humanity building monuments to our technological capability, reaching upward because we finally can, because the only limit was imagination, and that limit no longer applies. The Panama Canal cuts through Central America as an 80-kilometer artificial waterway that moves 14,000 ships annually between the Atlantic and Pacific Oceans. Before the canal, ships traveling between New York and San Francisco had to sail around the entire South American continent, a journey of 13,000 miles taking months, and exposing crews to some of the world's most dangerous waters. The canal reduced that journey to just over 5,000 miles and 2 weeks of travel, fundamentally reshaping global trade by making the Pacific accessible to Atlantic shipping. France attempted construction first in 1881, but abandoned the effort after 22,000 workers died from yellow fever, malaria, and accidents. The United States took over in 1904, first solving the disease problem by eliminating mosquitoes before attempting the engineering challenge of moving ships over an 85-foot high ridge. The solution was a lock system that raises ships in stages, filling massive chambers with millions of gallons of water until the vessel floats at the next level, then releasing them to continue their journey. The Gatun locks near the Atlantic entrance are the largest, lifting ships 26 meters in 3 stages, using only gravity to move the water. Each lock chamber is 305 meters long and 33.5 meters wide, requiring precise engineering to allow massive ships to fit with just centimeters of clearance on each side. The canal required excavating 238 million cubic meters of earth, creating Gatun Lake by damming the Chagres River and flooding entire valleys. Gatun Lake sits 85 feet above sea level, forming the bulk of the canal route where ships cross what used to be mountains before humans carved them away. The expansion completed in 2016 added larger locks that can handle new Panamax ships, vessels so massive they were designed specifically to be the largest that can fit through the expanded canal. These new locks use 1/7 to water the old locks through a recycling system that reuses water rather than releasing it to the ocean. Standing beside the locks, you watch massive container ships rise on elevators made of water, the entire vessel floating upward as millions of gallons flood the chamber in minutes. The precision required is astounding. Pilots guide ships carrying billions of dollars of cargo through channels barely wider than the vessels themselves, one mistake away from blocking global trade. The canal generates over $2 billion in tolls annually, ships paying based on tonnage to avoid the alternative journey around Cape Horn, where storms have destroyed vessels for centuries. This is geography rewritten by human need, 2 oceans connected because trade demanded it, proving that when economics justify the cost, we'll move entire mountain ranges. The International Space Station orbits 408 kilometers above Earth as the largest structure humans have ever assembled in space, a collaboration between 16 nations that represents our species' most expensive construction project. The station mass is 420 tons, roughly equivalent to 300 cars orbiting Earth at 28,000 kilometers per hour. Construction began in 1998 with the launch of the Russian Zarya module, followed by over 40 assembly missions that gradually added laboratories, living quarters, solar panels, and robotic arms. The station stretches 109 meters from end to end, larger than a football field, providing 1,000 cubic meters of pressurized living space for crews of 6 astronauts. Power comes from 8 solar array wings spanning 73 meters, generating up to 120 kilowatts of electricity to run life support, experiments, and communication systems. The station completes 16 orbits daily, experiencing 16 sunrises and sunsets as it circles Earth faster than a bullet. Astronauts aboard see the planet as a borderless sphere, watching storms develop. Cities glow at night, and auroras dance across the poles from a vantage point no amount of money could buy before the space age. The station costs over $150 billion to build and maintain, making it the most expensive object ever created, more costly than the entire Manhattan Project that developed nuclear weapons. Every supply delivery requires a rocket launch. Every crew rotation demands months of training. Every repair needs spacewalks where one mistake means death. The station's life support recycles 90% of water, turning urine and sweat back into drinking water, because launching water from Earth costs $10,000 per kilogram. Air is recycled continuously, splitting exhaled carbon dioxide into oxygen and carbon, creating an artificial atmosphere in the vacuum of space. Experiments aboard test how materials behave without gravity, how plants grow in space, how the human body adapts to weightlessness over months. The data gathered influences everything from medical treatments to manufacturing processes, discoveries that wouldn't be possible on Earth's surface. The station will eventually be deorbited, burned up in the atmosphere when its useful life ends. But for now, it remains humanity's permanent outpost beyond Earth. Looking up at night, you can sometimes see the station as a bright point moving steadily across the sky, a reminder that humans now live in space continuously, that our species has established a beachhead beyond the planet. This is our first step toward becoming spacefaring. collaboration, proving that when nations cooperate instead of compete, we can achieve what seems impossible. The Hong Kong-Macau Bridge connects three major cities across 55 kilometers, making it the world's longest sea crossing, a route that includes bridges, artificial islands, and an underwater tunnel. The project required 9 years of construction and cost $20 billion, employing thousands of workers who built in sections that met with millimeter precision. The bridge rises in sweeping curves over the Pearl River Delta, its cables forming graceful arcs against the sky, while traffic flows 6 lanes wide in both directions. 2 artificial islands were constructed mid-ocean to serve as entry and exit points for the tunnel section, each island built by sinking massive steel cylinders into the seabed and filling them with sand. The tunnel drops 33 meters below the ocean surface, allowing ships to pass overhead without height restrictions, while cars drive through tubes designed to withstand earthquakes and typhoons. The tunnel section stretches nearly 7 kilometers, requiring tunnel boring through seabed while maintaining waterproof integrity that protects drivers from millions of tons of water pressure. Engineers designed the tunnel to survive a magnitude 8 earthquake and wind speeds up to 300 kilometers per hour, forces that would destroy normal construction. The bridge reduced travel time between Hong Kong and Zhuhai from 4 hours by road to just 30 minutes, integrating 3 cities into a single metropolitan region. The project used 420,000 tons of steel, enough to build 60 Eiffel Towers, and 400,000 cubic meters of concrete. Corrosion protection was critical. Salt water destroys metal, so special coatings and monitoring systems track rust before it weakens the structure. The bridge is expected to last 120 years with proper maintenance, serving future generations who will regard this crossing as normal infrastructure rather than the engineering marvel it represents. Standing on one of the artificial islands, you watch the bridge arc away in one direction while the tunnel entrance drops into the sea in the other, a transportation system that seamlessly moves between above and below water. At night, LED lights illuminate the entire structure, turning it into a ribbon of light stretching across the dark ocean. This is China announcing its infrastructure capability, building on a scale and speed that seemed impossible until it was completed and open to traffic, connecting cities that geography separated for all of human history until now. The Gotthard-based tunnel bores straight through the Swiss Alps for 57 kilometers, making it the world's longest and deepest railway tunnel, a route that shortens travel between northern and southern Europe by 40 minutes. Construction required 17 years and $11 billion, using 4 tunnel boring machines that advanced 15 meters per day through solid rock. The tunnel runs up to 2,300 meters beneath mountain peaks, so deep that rock temperature reaches 46 degrees Celsius and requires constant cooling to remain workable. Engineers drilled 2 parallel single-track tunnels connected by passages every 325 meters, allowing evacuation if accidents block one tube. The boring machines weighed 3,000 tons each, rotating cutting heads studded with industrial diamonds that ground through granite and ice and every other rock type the Alps could throw at them. Workers extracted 28 million tons of rock, enough to build a pyramid larger than Khufu's in Egypt, using it to create construction materials rather than simply discarding it. The tunnel's gradient never exceeds 0.13%, nearly flat despite crossing mountainous terrain, allowing trains to maintain steady speeds without the steep grades of surface routes. High-speed trains now cross the Alps at 200 kilometers per hour through climate-controlled tunnels, while outside temperatures swing from summer heat to winter blizzards. The tunnel required precision alignment. Teams boring from opposite ends met with horizontal error of only 8 centimeters and vertical error of 1 centimeter after years of drilling through rock. Ventilation systems provide fresh air continuously because the tunnel is too long for natural air circulation to reach the middle. The system handles exhaust from 260 trains passing through daily, filtering air before releasing at portals on both ends. Standing at the northern entrance, you watch trains disappear into mountain, emerging on the southern side 17 minutes later, having passed beneath some of the highest peaks in Europe. The tunnel transformed European freight transport, moving cargo from Rotterdam to Genoa without slow mountain passes, and reducing truck traffic that clogged Alpine road for decades. This is infrastructure that treats mountains as obstacles to be negated rather than barriers to respect. Switzerland investing in a tunnel that serves all of Europe by making north-south transit as efficient as crossing flat ground. The Kashagan oil field operates in the northern Caspian Sea beneath $48 billion of offshore platforms connected by 200 kilometers of artificial islands and subsea pipelines. The field holds an estimated 13 billion barrels of oil trapped beneath high-pressure reservoirs containing toxic hydrogen sulfide that kills instantly. Extraction required technology that didn't exist when the field was discovered, forcing engineers to invent solutions for hostile conditions that destroy normal equipment. The oil lies 4,200 meters below the seabed beneath layers of salt, overpressured zones, and shallow gas that must be avoided during drilling. Ice covers the sea for 5 months annually, requiring platforms built to withstand crushing from ice sheets several meters. thick moving with current force. The field sits in water so shallow that conventional platforms couldn't work. Instead, engineers built 5 artificial islands from millions of tons of rock, connecting them with bridges and tunnels. Summer temperatures exceed 40 degrees while winter drops below -35, a 75-degree swing that causes metal fatigue and requires special materials. The hydrogen sulfide concentration is so high that exposure to concentrations above parts per million causes instant death, requiring gas detection systems throughout the facilities. Workers wear personal H2S monitors that alarm constantly. Evacuation drills happen weekly, and everyone knows that one leak could kill hundreds before anyone realized the danger. The oil contains 20% hydrogen sulfide by volume, requiring processing facilities that strip out the deadly gas before the crude can be shipped. The technical challenges delayed production by over a decade and tripled initial cost estimates, making Kashagan one of the most expensive and difficult oil projects ever attempted. When production finally began in 2013, leaks forced immediate shutdown. The pipeline corroded within weeks from the chemical assault of H2S-laden oil. Engineers redesigned the entire pipeline system using special alloys that resist corrosion, a fix that required 3 more years before production could restart. Today, the field produces 400,000 barrels daily, flowing through pipelines that require constant monitoring because one failure could poison workers and contaminate the sea. Standing on the platforms, you're surrounded by machinery that exists solely because oil prices justify developing technology for these specific conditions. The Caspian freezes around you in winter, ice grinding against platform legs, while workers maintain equipment that must function in conditions that would destroy normal industrial systems. This is extraction at the edge of possibility, accessing resources that require billions in investment before a single drop flows, proving that when energy demand is high enough, no environment is too hostile for industrial exploitation. The South-North Water Transfer Project moves 35 billion cubic meters of water annually across China through 3 massive canal systems totaling over 4,000 kilometers. The project addresses water scarcity in northern China by diverting water from the Yangtze River Basin, where rainfall is abundant to cities, and farmland where rivers run dry. The eastern route uses existing rivers and lakes. connecting them with new canals and pumping stations that lift water 75 meters, over 850 kilometers. The central route required building a new canal from Danjianka Reservoir to Beijing, a channel that flows entirely by gravity across 1,650 kilometers. The western route remains under construction, planned to tunnel through the Himalayas and redirect water from rivers that flow south into those flowing north, an engineering challenge that makes the other route seem simple. Construction began in 2002 with completion expected in 2050, making it one of the longest infrastructure projects in human history. The central route alone required relocating 330,000 people from villages that would be flooded by the expanded reservoir. The canal crosses over 1,200 rivers and streams, requiring aqueducts that carry water above other waterways, bridges that allow traffic to cross above the flowing canal. The project costs an estimated $70 billion, though final figures remain uncertain as construction continues on the western route. Critics argue the environmental impact is devastating. Changing river flows alters ecosystems adapted to natural water cycles, potentially destroying wetlands and fish populations. Supporters counter that northern Chinese cities would run dry without the water transfer, that millions depend on diverted water for drinking, irrigation, and industrial use. The project delivers 4 billion cubic meters to Beijing alone, nearly 40% of the capital's water supply, flowing through canals from 1,500 kilometers away. Standing beside the central canal, you watch water flowing north by gravity, pulled by elevation differences so slight they're invisible to the eye, but sufficient to move entire rivers across provinces. This is hydrology as megaproject. China deciding that water should flow where needed rather than where geography places it. Engineering that treats rivers as infrastructure to be relocated according to human requirements. Our journey through humanity's impossible megaprojects ends here, but construction continues worldwide as new ambitions emerge and technology makes yesterday's fantasies into tomorrow's reality. These projects prove that when we commit resources and engineering talent to a problem, even the most audacious dreams become concrete and steel. If this journey changed how you see human capability, share it with someone who needs to remember that we're living through the greatest era of construction in history. The impossible is being built right now, and it's only the beginning. Until next time, keep dreaming big, keep building bigger, and never stop believing that human ambition has no upper limit.